The question is security really that important? The real question is why are we even sitting down and talking about this? Is it about keeping your data safe? Is it about protecting yourself from hacks? Is it protecting and identifying the exploits? The conversation is all about those things and more. It's about understanding how you can keep your application safe so you don't end up on the front page of the local newspaper with the latest security exploit. And it's important to remember that security and identity are different things. Identity is how I know you are who you say you are, whereas security is preventing you from doing things I don't want you to do. The stuff that we're protecting when you think about it is all the data, all of the personal information, the lifeblood of what makes our business work. We have to protect that data and keep it safe. The threat is everywhere, and the enemy can be everyone. It can be external, it can be internal, it could be in your database. And so we need to understand what it is that we're talking about. In a perfect world, all we'd have to do is just get rid of all the data and allow no users. But the real world is that we have to assume that all users are evil and that all input is corrupt. In a perfect world, we could disconnect from all other machines, and our applications are going to be totally and perfectly secure. But the reality is, we need sharks with laser beams. But the real world is not so perfect. In the real world, it's very likely you're going to see some sort of cybercrime happen to you. If not you, then someone you know. A lot of these things happen in the U.S., but a lot more are happening from the rest of the world. 57 million Americans are receiving scam emails. Not just spam, but scam, where they're trying to go out and fish and get information from you, trick you to click on things that you shouldn't. In 2011, PlayStation got hacked. 77 million accounts got taken at once. In 1 year alone, over $1 trillion of intellectual property worldwide gets hacked. And back in 2013, in the holiday season, who can forget the Target credit card hack where over 110 million credit cards identities got stolen? In the real world, we're not so safe. Hackers are out there, and we need to be thinking how they think. The challenge is, it's an attacker's advantage and a defender's dilemma. The defender has to defend on all points, while the attacker can choose the weakest point. That means that we have to be thinking about our entire application, top to bottom, for the very creation of the initial configuration data all the way through to the application user putting in new information. The hacker can choose the weakest point and identify whether it's the network or the physical security or some cryptographic. But they can look for those weakest points and they can go out and try to find things. And that's the other thing. We can only defend against known exploits, while the attacker is constantly on the lookout for new ways to make exploits, finding new attack vectors, which means we have to maintain our systems and keep them patched. The defender has to be constantly diligent, while the attacker can attack at will. We may run our businesses from 9 to 5, but the reality is that 24 hours a day, all the time, the attacker can be sitting there waiting for the opportunity to pull the trigger. It's a company party. It's the holidays. They can attack when we're not paying attention. The defender must play by the rules, should play by the rules, but the attacker can play dirty. And that means that while we can try to identify what's going on, we can't break the law in trying to protect ourselves. So the goal is to build secure apps from the beginning. And in order to do that, there's a number of different things that we need to keep in mind. First of all, we need to be thinking of designing the application with security up front, right at the very beginning. We don't add security at the end. We think about it all the way through. We think about how we can secure things with defense in depth. It's not just the application or just encrypting data as we store it, but it's also thinking about the network, and it's thinking about the operating system. It's thinking about how we're running our services. It's thinking so that we're looking at all the different layers of that onion that is the defense and making sure that we've got the appropriate defenses in place at each level. We need to follow secure coding techniques. We need to make sure that we're paying attention to what those are for like memory overflows and things like that. And we need to use those in our application design process. Know your threats. And a great way to do that is to pay attention to OWASP, which has a list of the top 10 threats. And finally, engage in threat modeling so that you know what your application's exploit vectors are, so you have a good documentation of what you're thinking as you're building the application. So what is that security mindset? What does the developer need to be thinking about when we're building applications? How do we get into the secure mindset? Well, first of all, you need to be understanding what it is you want to have. You're building an application that has some sort of a problem it's solving, but there are problems you don't want to create in the process. So you want to have a secure application that's going to take the security and cube it and talk about the 3 Ds: secure by default, secure by design, and secure in deployment. And that means that when we build our application, we're building it to not go out and have some open exploits that are just sitting there. Things like having a secure password policy that requires some complexity to it, or having built into the application the encryption of the data in storage. And the secure in deployment is talking about how do I actually build the application and install it so that it doesn't install and run as an admin and require the first user to go in and have all of the rights. You deploy it with only the needed features, the required features turned on, and then you enable things as you go forward. We think about defense in depth, and we think about all of the different layers of security. We talk about running in least privilege, and that is understanding that an application that is going to be going out and reading and writing some data does not have to have admin rights. An example of least privilege comes back to I donate blood. I've given about 8 gallons of blood over the last 15 years. And in the place where I donate blood, they had an exploit a while back where they lost one of their laptops. And so the next time I went in to donate, I was curious to see what they were going to do. And they were thinking that they wanted to protect my privacy. And in the interest of privacy, they decided that having the nurse ask me all those questions that they need to ask in order to keep the blood supply safe, they didn't want the nurse to actually be in the room while she was asking me these questions. So they created a computer program that would narrate the questions to me, and then you could click yes or no, but you'd have to wait for the narration to finish. And there's about 40 or 50 of these questions. And so I was given the laptop. The nurse said, "Here, answer these questions." She started the program, and then she left the room. Now, being an impatient kind of person, I was looking at the laptop, and I'm waiting for the next question to finish narrating. And as I was doing that, I right-click on the Start menu, and lo and behold, it says Explore All Users. Now, what Explore All Users means is that I'm logged on as an admin on this machine. And being the curious type, I wanted to see how far I could go in the program. So I right-clicked around, I opened up the Explorer, made my way, put in my thumb drive, and then later when I got home, I called up their support department and got through to the director of IES, and I asked him, where should I email your database to? If they had been running with the concept of using least privilege, I never would have had access to get to that machine. And then finally, if you do have a failure, you want to fail into a secure mode. And that means that I'm not going to fail to a open up and here you've got the keys to the kingdom, here's all the data. You want to make the machine and the application as non-functional as you can. So if you're going to fail to the secure mode. Talking about defense in depth, we're talking about the different layers of how an application gets built and gets deployed. There's the perimeter, there's the data center. This is where you're running the machines. If you're running on-premise, that's your data center. Think about how you've got this $1 million, $1 billion data center where you've got all of the different security and the retina scan and the thumbprint reader and the secure code. And then someone decides that the air conditioning isn't working, so they prop open the door with a garbage can. How secure is that? You have to be thinking that thieves, just like maybe myself when I was giving blood, might have ulterior motives. Might be your employees. They have a thumb drive and they can get physical access to where your data center is and where the servers are. So when you're thinking about defense, how can you prevent that from happening? Make sure that you're using the security devices. Don't set the alarms to mute just because it annoys someone. Make sure they're turned on and that you're paying attention to those perimeter alarms. When you think about the network, this is how we get through the firewall. Think about viruses and worms. You need to be making sure that you have the appropriate network monitors in place and that you're blocking unnecessary traffic, that you're not opening up ports just by default. Only open up the ones that you have to and that you are required, and then make sure you're monitoring the ones that are open. The next layer is the host, the operating system. You want to be running, there's a number of patches that come out, so you want to make sure that you're installing those patches, because these will protect you against new patterns for different kinds of viruses and exploits and worms that come out. Running an unpatched machine is just setting yourself up for potential errors and potential exploits. Then in the application itself, and this is where the developer really comes in, we're talking about how do we apply the secure coding techniques to prevent against known exploits and to be aware of other types of exploits that could happen. And finally, think about the data. At the very core of all this, you've got the information you're trying to protect. Why not encrypt it when it's at rest, which means when it's not being used? Encrypt it, use hashes. Maybe don't store a credit card number. Maybe you store just the approval code or the other piece of data that can securely be used to complete the transaction. So what you want to do is you want to make sure that you are using encryption to protect the data when it's not being used. Add access control things to prevent access. Make sure you're using identity and authorization techniques to prevent access from unintended users. We think about secure coding techniques and we talk about, what are those techniques involved? What do they include? One of the first ones is the access control. What kinds of access does your code or this particular part of the application require? And then go out and request it or grant it as needed. But don't give the keys to the kingdom, because if you do, you might run into something where you get an exploit and they take control of things and then unintended consequences occur. So things like running with least privilege by default. So make sure your application can run with whatever privileges it needs. Test it with the least privilege account. Use cryptography. And there's a number of different ways that you can use encryption. There's symmetric and asymmetric encryption. Some of them make sense when you're running in different scenarios. If I'm going to be encrypting and then reading the data back and forth a lot, you probably can get away with a symmetric encryption, which means that I've got one key that encrypts and decrypts everything. If it's something where you're sharing across a boundary, think about asymmetric encryption. This is a little bit more load on the processor. It has a higher performance impact on what's happening, but it's also a little bit more secure because I've got a public key that I use to encrypt the data and then a private key that is completely different that I use to decrypt that data and be able to make use of it. Make sure you're protecting your secrets. In this sense, we're talking about making sure that when you've got a key to like SendGrid to be able to send email or a username or an API or all of those pieces of data, that it's not being stored someplace that people can get to. If I'm doing a deployment, make sure I'm using an encrypted, protected secret. Those secrets are what we're trying to protect. Next is to assume that all input is evil. And in fact, you could translate that to say all users are evil, because all users, until proven otherwise, could start running exploits without your knowledge. And then you're just going to have to try to make sure that you are checking and validating all the input. Make sure that you're validating data before you display it in the screen. You want to make sure you're looking for exploits that are happening at the time that are coming from the user. But there's also persistent kinds of attacks that can get you if you're not paying attention. So assume all input is evil and that you need to make sure that you're validating and that the data is correct and matches what you expect, And then finally, make sure that you're encoding it when you're displaying anything. There's a concept of whitelist versus blacklist. And there's blacklist validation where I have a list of all the evil things that I know about, all the bad exploits. I could put that into a list, and then I use the blacklist to go out and check for the existence of these things. That is different than a whitelist, in which case I am going out and I'm specifying what I expect good input to look like, and I'm defining only the things that are valid. Whitelist is generally looked on as being better than the blacklist, although blacklist is better than nothing. Let's talk for a second about threat modeling. What is threat modeling? I've mentioned it before. You should use threat modeling, but what exactly is it? What threat modeling is it's a way for the designers of an application to understand where the data is, what we're trying to protect, the vectors that could be used to exploit that data in that application, and then to give us some rating and some understanding of where we should be spending our time and to understand what those threats are. We really go through a 6-step process of going out and, first of all, identifying what our objectives are. Maybe our application needs to be able to go out and support 10,000 users concurrently, and we need to be able to capture e-commerce data, which includes some secure, sensitive credit information, in which case our security objectives is to make sure that that data never gets exposed and that we're protecting it across the wire, that we are preventing any denial of service attacks by having the appropriate tools in place. And we take those objectives and we create an application overview that kind of defines all of the places where that data lives, where it's flowing to, where it's being accessed, all of those points of interaction. And we really literally go through and decompose the application down into a list of what those things are. And then we identify the threats at each one of those levels and say, okay, well, here's the different kinds of attacks that could happen. Here's an injection attack. Here's a SQL scripting attack. Here's the buffer overflow that could happen. But by identifying those threats, we can then use that to identify our vulnerabilities and understand where are we potentially at risk. Can we close all of these things off? It'd be, in a perfect world, it'd be great, but there are the unknown attack vectors that we don't know about. So how can we make sure that we're identifying and trying to prevent things from happening? And finally, it gives us a way to take that data and then rate that into the areas where we need to have plans of action as we go through and build the application. Stride is one way for threat modeling to look at the impact of a given vulnerability. And there's a different ways that these things can happen. S is for spoofing. That is where I impersonate another user by giving false credentials or a false IP address. I basically pretend like I am coming from a valid source when I'm actually not. T is tampering. That's where I take a request that's in flight and I change it or I modify it. For instance, I might have something that says, go out and buy this product for $10, and I tamper with the request and I say, buy this product for $1, and have some sort of validation thing happening. Tampering is where the data actually gets modified. Repudiation is where I make a change, but then I cover my tracks so that you don't have a log or you don't know what happened. So you need to be thinking about how do we prevent repudiation attacks. Information disclosure is where we have unintended data being surfaced. In .NET applications, there's this thing some people call the yellow screen of death that sometimes you get on an application where the compiler doesn't know what to do, and then boom, it pops up and you get a stack dump of where in the application something failed. That information dump has a lot of very valuable information that a hacker can use. Things like, oh, I failed to insert, or this data type was not an int, and I expected a string, or the other way around. And then it failed to insert into this table, or maybe this column wasn't there. All of that stack information gives the hacker data that they shouldn't have. So you need to be careful about the information disclosure. Denial of service is where your application is so busy processing and working that it's unable to handle the rate of new requests. So when you're thinking about denial of service attacks, thinking about, what is it that can be happening here is that someone's flooding your network with the advent of these bots that can get installed to people's machines inadvertently, these armies of bots can be wielded against us in ways that you might not expect. And all of a sudden you have a million requests that prevent your valid users from getting into the system. And the last one is the elevation of privilege. And this is where someone is able to find some exploit, break into your system, and then while they're there, elevate their privilege level to do administrative harmful things. So you want to be thinking stride: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. Fortunately, there are some free tools that are available from Microsoft. The first one is the Attack Surface Analyzer. This is a tool that you can use to go out and run it against an application, and it will come back and give us a list of where the attacks are possibly going to come from. A second one is a threat modeling tool. Yes, it's a fairly complex process, and fortunately there's a nice tool that allows us to actually even go out and model our applications using an active designer to go out and create what our application looks like, and then inside of it create the identify and document what those threats are, and it will help us to surface and be able to use that. There's also a couple of other ones for fuzzing, which is where we want to be able to go out and do some exploits where we're using a sparsely populated mechanism. There's a mini fuzz as well as a regular expression file fuzzing tool. You can get all of these at Microsoft.com by going out to the security/SDL. In fact, let's take a look at the threat modeling tool. So let's go out here to SkyDrive. No, sorry about that. Wrong release. Let's click down to the desktop, and here I'm browsed out to Microsoft.com/security/SDL. This is where the team from Microsoft that does the security development lifecycle spends their time and makes it easy to go out and find tools and information about how to work your security process. One of the tools, or there's several tools that are available. The Surface Analyzer allows us to go out and take an application before and after it's been installed and then be able to identify attack surface and figure out, what is this doing to our server and our system. The second one is the threat modeling tool, and that's the one we're going to take a look at here. If you click on the download, it'll take you to a page where you can download it. It's a free download. It's very small. But once you've done this, then I'm going to go out and I'm going to run it. So come over here, and I'm going to run the threat analyzing tool. And what this has is it's got a way to go out and dive into how I can model my application. It actually even includes a drawing surface. So if you have a model, you can open that up. But if you want to create a new one, just click on Create a Model. And you can see we've got a design surface here. And on the right, we've got stencils for our process, for the boundaries, for the flow of data. We can go out and we can say, let's start out with a web server, which we can drag onto our site. We've got a boundary, which would be a generic trust boundary. We can just kind of drag that and put that on here. And we can put our web server inside of our trust boundary. And then we might have some users who are going to be going out to connect to this. So from the external, you've got some browsers. You might have another application that's going to connect to it. You've got some flow of data going through, say, HTTP, which I can drag onto the page. And I can connect this up to the different spots. So you can go from the web server down into the browser application and connect it. And this is a nice little tool that I can use to kind of show what's going on. And as you look down here, you're seeing errors that are showing issues. So for instance, if I've got an application or a process and I just drag a database, for instance, and I put my data store into a SQL database and I overlay or put it into the wrong spot, I'll get messages saying that something's not right. And as you can see down here on the bottom, the entities in the diagram should form a connected graph, and they don't right now. So I can say the web server is going to actually get data from there, and I can use a binary or a UDP kind of connection to be able to do that. So let's use named pipes, and I can connect that up to my SQL database because it's running on the same machine. And so now I've got my application, and as you can see here, I have a list of what's going on, and I can work through my errors and make sure that my data is actually set up right. Once I fix all of these errors and get this to a point where the diagram makes sense, let's connect that up there, then these errors will get cleared out and you'll see that there's no issues. Now when I'm done with that, I can go out and say, okay, I want to see what kinds of issues there might be. So I'm going to click up here to where I can switch to the analysis view, and this will then take my application and give me the different types of threats. And you can see here we've got spoofing of the web server. And we say, okay, well, this is a high possibility that's running on spoofing. If you expand it out, I can see here's a description. If we don't want to do something to mitigate it, we can document what it is that we're thinking and why it is that this is set up the way that things are working. So this tool, it allows us to go out and create this. We can also generate reports and create a full report on this. We can then have documentation. We can save it out. You can switch back to the design mode and be able to work through other aspects of how this tool works. But you can also add notes so that you can say, okay, well, here's how we've put together this application architecture. So the threat modeling tool allows us to go out and work with our applications and give us that documentation saying, how does this thing put together?